Hello, hello, hello. Wait, shit. Okay, there we go. Hello. How are we doing, chat? Fuck, hold on. Shit. Fuck. There we go. How are we doing, chat? I'm doing pretty good myself. Let me hit the transition. There we go. So yeah, last stream, kind of. Oh, let me turn that down a bit. Last stream I kind of was struggling a bit with some of the stuff just because the documentation was a bit unclear. I worked through that kind of this week, just kind of to get it out of the way. And as it is now, I kind of have all of the or have all this part working. There's, there are some bits that I need to clean up. So I mean, as an example, over here with the display area. Oh shit, my phone. Hold on. Moving stuff, hold on. There we go. So for example, over here with the display area, right? This doesn't really mean anything. I mean that's one specific thing I need to clean up. But for most of this, I've kind of got it. I've got it in a place where I'm happy with most of it. There's a couple of things I need to clean up. There's a couple of things that I also need to try. But for the most part, I'm happy with where it is. And so if I hold on. If I swap over, where's the view? There we go. This is kind of the result of what we have, right? It's just drawing a triangle. And in fact, if we go over to, I don't know if this will show up. Hopefully this shows up on stream. Will that show? What about now? There we go. Okay. Just ignore the output bit here for now. But here we have the VRAM viewer of the simulator, and kind of looking at our code and looking at the VRAM viewer, we can kind of see that we clear this background, we draw this triangle, and then that's it, right? We're not doing anything else. We could, for example, draw more stuff here, but the important thing to kind of do next, at least in my opinion, is double buffering. So double buffering, if you're not familiar, because I'm sure there'll be people here that aren't, it's a pretty simple technique. One sec. Just taking a bit of a swig. So double buffering is pretty simple. Essentially, instead of just having one thing that we're rendering to here, we're gonna have two, right? With the idea that one is the display buffer and one is the draw buffer. So we have one of them that we're displaying and one of them that we're drawing to, and this way, kind of, well, actually, no, let me take a step back. We have one that we're displaying, one that we're drawing to. We draw to this draw buffer, and then once we finish drawing, we swap them, right? So now we're displaying the one that we were just drawing to, and we're drawing the one that we were just displaying to, so we're reusing it, right? And this way, the end user never sees kind of any in-progress rendering, they just see, the finished product, right? And this is a, super common technique. it's a super common thing to do, right? Basically, every 3D renderer ever does at least double buffering. More modern ones will do like triple buffering sometimes, but we're not going to get into that. But yeah, so my goal for today is pretty much just to get double buffering working, and specifically reworking some of the code so that instead of this just kind of drawing a triangle once, it's continuously in a loop of, clearing the screen, draw a triangle, clear the screen, draw a triangle, whatever. Because that way we can, that's kind of, your natural game loop. But also, as an example, we could easily kind of just move the triangle a bit each frame, and we'd have kind of a very rudimentary kind of animation. So, yeah, with that being said, let's swap back to the code. Now, I do very quickly need to just kind of commit the changes I have with this, which will just take me a second. There we go. Okay, cool. I just need to add a comment up here quickly. Which thing is it for? Display image. Okay, cool. So, disconnect that actually. Okay. So, the first thing we're going to do is we're going to just remove this triangle code here, because in this context we're just going to clear our 2-frame buffers. So I'm just going to comment that out. And since we're going to be double buffering, we're, instead of just having a display and draw area, we need 2 of each. Specifically, display area for the first buffer and draw area for the other one, and then vice versa. Right? So up here we can just say display area, display areas equals now first one is just going to be same as before. So we're starting by displaying kind of the first block of VRAM, which should be clear at this point, but yeah. Now the second display area is where do we want to put it? So, where we can put the draw and display areas, that's kind of another question. Some cases I've seen people have them next to each other in the PS or in the VRAM. Some will have them kind of above or below each other. I'll probably do the second one for now. It's not that big a deal in this context. I think there might be a difference between the two, but I honestly wouldn't know. Um, so yeah, we'll put them below each other. In which case our second display area is just this plus the back buffer height. I believe that's correct. Yeah. Is that always changed for that? I think so. Let me just double check my constructor. Yeah, okay, cool. That should be all we need to change the display area. Drop areas. And this is going to be similar. So one of the big differences here is that kind of we're going to want each of these to be pointing to different parts of VRAM to make sure that, you know, the area that we're drawing to and the area that we're displaying are always opposing. So let's see. The X that we're clearing is always going to be the same. The Y is going to be different here. Back height. Top left is going to be that plus back buffer height. Our bottom right is going to be the Tamagotchi's beeping at me. Oh god, hold on. I thought I'd put it to silent. Okay, there we go. Which one was I doing? This one, yeah. So our bottom right, the X is going to be the same. The Y is going to be, well, just that times 2. Do I want to swap these around maybe? Actually, shouldn't really matter. Okay, so yeah, in this case, if we have this kind of a display area, or if we have a kind of 2 buffers above each other, this is the top, which is referring to the top one, this is referring to the bottom one, this is referring to the bottom one, and this is referring to the top one. Yeah, okay, cool, that's correct. Okay, so we can get rid of that for now. And we are going to need a frame counter. U8. So to initialize, we're gonna display areas, frame counter, set, and draw areas. Frame counter dot set. And in fact, if we uncomment that just for now, and we head over to the emulator, let me have a Okay. So hit run on that. We should still see the same thing. Oh, yes. Okay, I'm being silly. Yeah, get rid of that for now. Okay, yeah. So we initialized, kind of set those up. Display's not really a great name for this. Just remove this one for now, actually, I guess. Frame counter plus. If that's greater than 1, then we're just going to set it to 0. Okay. So in that case, actually, we can remove this setting there. Move this up here. So we set up display and draw areas. We draw. We then create the frame counter. We need to wait for either VBlank or just GPU done. And then go to the next frame. We then set up the new display and draw areas, draw to them, blah blah blah. Okay. In this case, we'll just wait for GPU done. I don't remember if I've actually added that at all. Don't think I have. No. Okay, that's fine. We will swap over to the documentation. There we go. Okay. I'm just gonna skim through real quick, 'cause I don't remember where it will say. I think it's above here. Yeah, here it is. Ready to receive commands. Com, which is bit 31, bit 29, bit 28 of the GPU status or GPU control. I have the register GPU control. Okay. So we'll just what am I doing? GPU done, yeah. Wait for GPU ready. So yeah, each frame we wait until the GPU. Oh, I forgot to swap over the code. Okay. So each frame we wait for the GPU to be ready, set up our display and draw areas, draw primitives, and then increment the frame counter, and then keep going. So, I think it's bit 28 of GPU control. So I'm gonna say while this and 28 and 28. No, this is not the cleanest way of doing this. Realistically, you know, we want to mask it out with constants and stuff, but just kind of getting a quick hack in for now. That should be fine. I hope that says volatile, yeah. Okay. So let's give that a try. There we go. Position. Okay, let's check the VRAM viewer. That doesn't seem right. That's weird. Why did that get stuck here? I think I got the constants wrong. Hold on, let me check some sample code I wrote in the past. Let me just see. Oh, this should be. Not this. I believe if I just double check, that should be. Six. Oh, I see. Okay. I was misreading the documentation. Let me show you. Uh, so we should be reading this busy bit here, which is if the GPU is busy, not this one. I'm honestly not 100% sure what the difference is, but... Oh, well, no, I'm not specifically sure what the... Well, no, yeah, because in theory, if the GPU is ready to receive commands, it should be ready to do other stuff, but who knows? Who knows? Anyway, yes, it's bit 26. Which I'm just gonna add a quick constant for. What would we want it to? I guess GPU status. Yeah, GPU status feels fine. Enum GPU status. GPU underscore idle. Okay. GPU status. I should probably rename that to just be idle. So it's a bit less kind of wordy. I don't know. Okay. Okay, let's write GPU data. Oh, whoops. Semicolon. Okay, let's give that a try. Let me swap back to our multi-view. There we go. Okay, run. And let's see what we get. Okay. Not sure why the triangle is only showing on one of those two. No, I think I know why actually. I have an inkling. So one of the... I forgot the code. One of the things that we set up in this is the drawing offset. My guess is that it's just the drawing offset is wrong in that it needs to be kind of, you know, specifically where the frame buffer is. I assumed that this was relative to the frame buffer, but I guess maybe not. I'll double check the documentation. Where is it? Okay, they're offsets in the frame buffer. So they're not relative. Okay, yeah, that'll be why then. So we need to set this to init draw y plus back buffer height. And that should be correct. Why is that not? There we go. Make run, and it should just display the triangle. No, that's still... Why is that still flashing? Let me hit pause. Our VRAM viewer. So, okay, we're only drawing it in the top. Oh, you can't see this. There we go. Okay. So, for some reason, we're only drawing the triangle here. Now, this emulator, if I go, where is it? GPU logger? Yeah, this one. This emulator does have a GPU logger, so we can just kind of turn this on and hit start. If we just let's pause F6. Stop it here, I guess. We're getting a lot of commands. Because we're not waiting for VBlank. Yeah, that... I mean, that doesn't seem like it should cause an issue, but... Well, it doesn't seem like it should cause this issue, but... Yes, it's probably not the best thing to do. So... Let's go about adding VBlank... Or waiting for VBlank. Now, I don't remember how that is, or how you wait for VBlank. I think it's just an interrupt. So let's go to documentation, VBlank. I do have some code somewhere that actively... Oh, let me go back to that. VBlank. Ugh. Interrupt. This doesn't say anything about VBlank. Oh, there is an interrupt mask here, and that bit later down did say about an interrupt mask. Let me double check the thing I have. So this is where is it? Status register. Where memory is that? Hmm. Does this just not? Hold on. Interrupt. Okay, so this is the. If the mask register is 7.4, then the status register is probably 7.0. Doesn't go into more detail than that, but that feels like a decent assumption. Yeah. Okay, let's go back to the code. Okay, new file, GPU.cpp, include GPU.h. Move that over just because that should probably part of that. We can add a wait for vblank. Wait for vblank. Wait for vblank. I think that's how I added capital B. There we go. Correct definition. So, our interrupt register was something along the 7.0. So we can just add that as a thing here. If I copy the definition I have for now, IRQ status, or yeah, IRQ status is fine. What was the address? There we go. 7.0. Okay. So let's see. Okay, so we need to figure out how to kind of read the interrupt status from this. But in theory, the code we'll have will just kind of be something kind of like what we have for wait for GPU, where we're kind of just saying until, or just repeatedly kind of wait whilst we're waiting for this and some value. In this case, that'll be kind of IRQ, blah blah blah, or VBank. I don't know why. Yeah. So we should probably just make. I'll just do IRQ.hpp pragma wants. Can move that over and I should include IRQ. And we can just copy. Well, yeah, we'll copy GPU status, I guess. IRQ and VBlank equals. I don't know what it equals, but we're just gonna set that for now. IRQ VBlank. Now, one thing I do need to double check is these while it's because this is set to a volatile address, it should be fine, but I mean in reality kind of, you know, compilers can be a bit of a pain. Is there anything else we need to do? I don't think so. Okay, so let's see. Let me go back to documentation. There was wait, there was something in mask. So many words so little time. Exactly. The worst thing with this is that the this documentation is like not, it's not the best. Oh wait, hold on. Um, yeah, this documentation looks like a scientific paper now. Redwood Shore. Yeah, this is this is what um this is what technical documents look. I mean, if anything, this is relatively amateurish for a technical document because this is kind of purely kind of community made. I mean, if I hold on, let me check that this would show up actually. Because I've been reading for a separate thing. I've been reading some stuff to do with like the CD format, so I can kind of extract stuff from CDs, and that one is a nightmare. uh, Here we go. What is this song? I'm skipping this. There we go. CD's nuts. I'm not mad. I'm not mad. Let me check if that shows up. That does. Okay, yeah. This is this is this is this is the form or the document for she's molding. I'm not molding. I'm not molding. This is the one for CD-ROM format. It's data interchange on read-only optical data discs. Obviously. Yeah, reading through this one has been a nightmare. Stuff like this is written in a way where it assumes that you already know, like, she on my detail I ROM. It's so true. But yeah, I mean, you can already see this one's talking about F1 frames. It's shit like this. It's just... yeah. Kind of making any heads and tails of this has been a mess. I'm working my way through it, but yeah, this is the kind of... this is basic stuff you're supposed to know. This, the thingamabob. Exactly, it's the thingamabob. Oh god, what was the other thing I had to look at? Titanium ABI. That was another one that was... Titanium ABI. I spelt it wrong. Okay, that's not displaying properly. Just imagine you can see this. It's very dense. Anyway. Okay, so the CP field can be used to mask hardware and software interrupts. IM10 used to mask software interrupts. 7.2 masks 6 external interrupts. 0 disables an interrupt and 1 enables it. Okay. Hmm. phrase not found. Ooh. Okay. So the issue now is I know wait, I see. Love my Windows error.wav. Exactly. Windows error.wav is like it's peak. It's Peme even. Fuck. Interrupt enable current. Current global interrupt enable state. Let me. Windows error.wav my robot GF malfunctions. So true. I mean, I'm. Damn. I'm surprised that she doesn't just, like, make the Windows logging off sound. I might. Okay, wait, hold on. Given this interrupt enable current, I might be able to just write a. What do we have, 1 or 0? Just write a value to that and have that work. Let me swap back to VS Code. So, if I'm understanding, I mean, this wouldn't be vblank. We need to rename it, but because it was the lowest bit, if we just check for it, and then I think we'd need to flip it so that we're actively setting vblank as IRQ status equals inverse of IRQ vblank. I mean, again, it's. I don't think that's actually vblank. I think that's just exceptions, but let's give that a try. Run. I'm just gonna see what this looks like first. Okay. It's not quite right. Good thing I didn't display that on screen, because it's flipping between two states very quickly. So I mean, I don't think that okay, the words. Let me swap to the emulator. So, yeah. Looking at this again, we're only drawing the triangle in one of the two instead of both. But I mean, the actual output we were getting did seem better now. But let's look at the GPU logger. Seems correct. Oh, our drawing offset is always 0. That's probably not right. That's definitely not right. Okay. Well, that's the problem. Now I just gotta figure out why that's happening. I thought I set this. I set it to Y value. I'll set it to 8-bit. That'll be Y. This is the draw area. Drawing offset. So primitives. Where is it? Draw offset. Let me go back to the documentation. Which is drawing offsets. I think I've got the size of that wrong. Could be that the documentation is wrong here. Because, I mean, there are a couple things the documentation is just blatantly wrong with. I forget the exact detail. There's like, it's either the display enable thing. Oh yeah, it was this display enable. It has these two the wrong way around. So if you follow this, you'll be turning the display off, or you'll be disabling it when you want it to be on, and vice versa. But it's literally just that they're the wrong way around. But yeah. Okay. Draw offset. Yeah. So I mean, this is saying that this is only 4 bits, but I mean, it also did get these parts wrong. So maybe that's. Let me see what I did in other cases. Okay, yeah, I'm pretty sure that that's wrong. Cool. So it's 10, 9, and then that needs to be 5, so this is still size of 4, yeah. Change that to U16, so it actually has enough space. And it's up to date. I guarantee it's not VS Code. Ugh, I still need to set up a proper, like, make delete, so I'm just gonna... Right? Yes. Make, I'll just do a full rebuild. Okay. And if we swap to... Where's my PSX? Closed it on accident. That's fine. I'm gonna set this to the smaller one, so if it does flash at all, it doesn't hurt anyone. Okay, let's give that a try. No, that's still... Why is that still wrong? Did I not set up the code properly? Maybe let's check the GPU logger. Logging, breaking vsync. Where is it? That just doesn't seem to be drawing it, or drawing the... doing the draw offset at all. That is 4 bytes. is that wrong? Draw offset. Is that sized correctly? Command is set properly. Offset Y and X should be set properly. And yet... Let me undo that change. Just gonna see what we get. Because I think well, I mean, okay, we know that it is specifically just something about the drawing offset here that's wrong. I'm just not quite sure what. Let's remake it with the old incorrect values and hit run on that. Yeah, so we do get the drawing offset here. 128. That's 128? Where's 128 coming from? Huh? Oh god, okay. Is the code coding? It's... well, it's doing something. Something about the way that I'm writing this is not correct. That sounds healthy. It's... no comment. Okay, let me go back to what this should be. That should be correct, because I mean, in that case, with a 10 and a 9-bit value, which I've set up correctly with these, and that's following the same format. Yeah, our draw offset is 256, well 0, 256, and then 0, 0. So this should be correct. Let me relaunch PSX and reconnect. Yeah, and we still get the flashing. Let's check. Hold on, let me swap to just PSX. Okay. Let's see. We do the draw area bottom right, then the drawing offset, then the mask state. So it should be between these two. It's just kind of not. Oh, those Y values are wrong. Then that wouldn't. Okay, I think I know what it is. I think if I just swap over to here we go. I think the problem is the draw area bottom right part here, because we initially we were having this as a, well, they were having this be 512, but that would wrap back around to 0. So this wants to be 511, I guess. But the rest of that should be correct. It could just be that that part was like confusing it. If we swap back to our multi-view, let's give that a whirl. The draw area part is at least correct now. But that drawing offset still not there. Let me check. There's another emulator I have that's more accurate, but it's also kind of a pain. Let me try it in there. Let me make the disk image. I pulled the emulator up, and before I'd even hit run, just because I wanted to kind of see what it would do first. Yeah. Okay, hold on. So something about this is wrong, about the drawing offset. Good old Windows error.wav. Exactly. Okay, make and mulch. Hello. I love mulch. Hi Zainab Mulch Girl. Hello. It's me. I love mulch. Let me see if I can get this emulator up on screen. Because this is a different emulator. I don't have a good setup for this one, so this is just going to be... oh god, where is it? Okay, this is not great, but this will have to do. So, this is kind of the VRM viewer of no cache PSX, and this seems to be showing a draw area offset. So we do our text window, or text page, text window, that draw area to there, so the offset to 0, then do the triangle, okay. And then if I put this to be at the next frame, but I want a frame where the triangle isn't on screen. There we go. Okay, so draw area offset still 0. Let me swap back to the code. Okay. So, I don't know why this would be wrong. So I'm just gonna try... Oh, wait. I'm stupid. I think I realized what the problem is. So, if you look in the documentation, it is saying that offset Y is only 4 bits, but it's also saying that it's, you know, whatever value, left shifted 11 times. Which, yeah, so maybe it is correct. Maybe I do just need to I mean, in this case, right shift, but yeah, let's give that a try then, I guess. So yeah, that was 4. Drawing offset, so would be this value, right shifted 11 times, of 11, which will give us 0. Can't be shift 11 times then. Maybe it's just a different amount of times. Like, let's just try setting that to a value of 1. Let's see what we get. Multi. I need to reopen PSX. Okay. Okay. So remade, hit run, and GP logging. X of minus 1024. What? I'm not sure why that drawing offset is like 1024. But let's see. If it's assuming it is a 4-bit value, which is what it says it is. Let me just double check I'm actually setting these. Yeah, offset X, offset X, offset Y, offset Y. And I'm setting the command. Just drive 255. I mean, it'll be too big, but it should at least set it to a value of all 1s. Stupid. Sometimes when it comes to messing with VRAM stuff, I have to relaunch PSX, which is annoying. Okay, so we still get flicker. If we turn on GPU logging, it's offset 0, 0. That's on 24/7. Okay, wait. I think this just means then that the X is a couple bits bigger than the documentation is saying. So in our case, primitives. Let's say that's 12. And then that's, well, yeah, I'll just leave it at 4. If we make that 2. Make up to date. It is not. Okay, make run. No, I need to relaunch PSX. There we go. Okay, and GPU logging. Okay, but that does mean we're not setting the X anymore. So I was correct about the X, that it's just larger than it was saying. 30, what would be the binary value of 30? 32 is just a 6-bit set. So 30 would be minus 1 be all bit set. So 30 would be just that, but not the lowest bit set. So we've made the X 1 bit too big. So that's 11 bits for some reason. I'm gonna just assume, I don't know what size this would be. I'm just gonna assume that this is the rest of this. I'm just gonna say 9. Because it makes sense to be like, you know, allow 256 as a value. In which case, what size would this part be? That'd be 20, just 4 bits. Yeah. Okay, and we can just set this. Yeah, that was right. Oop. Oop. Okay. Make. Relaunch everything. And hit run. And let's see if we get. Whoa! That's worse. That's worse. Okay. I'm gonna assume that's because I made this too big, which... Oh, that should be 16. Anyway. No, I mean, we can just give that a try. Up to date. It is not up to date. Hit make. Okay. Let's see what we get now. Now that's the right width. Still getting the flashing. Maybe I just got the size of that part wrong again. Let's. So that's 255. Try that instead. I think that feels like a more reasonable value, maybe, I don't know. Or not. It's not showing the... I'm gonna check the other emulator, the more accurate one, because I'm not sure why that isn't. Why that isn't right. Bear with me. Undefined opcode again. Why? Why though? Why though? Undefined opcode. Ugh. Okay, let's try that again. Okay, I'm gonna double check that in this emulator. But I think we've almost got it. It's just that it's like very slightly off. Oh, stupid. Gotta open and close the emulator for some reason. I don't know why, it really just doesn't like changing like graphical stuff. I only ever seem to have to reload it with graphic stuff. Okay, yeah. So here it's literally off by like a pixel, so you can see it's like... Actually, might not be able to see at that size. There we go. You can see here that it's just like... So it is literally just off by a pixel, which means that that is... means that the offset X is 10 bits. So if we remake that and double check that in the more accurate emulator. No? Huh? Why would that be? Oh. GPU logger. what, 11 bits and 8 maybe? That doesn't seem... that would be right. Let's give that a try. Oh, it's on the wrong... No, that's... So close to having this working. And yet... it wants to be temperamental. Yeah, that's still... okay. Check more accurate emulator. Let's see what that says. Okay, there we go. Remake that and see what that outputs as, because that, I think, will hopefully be correct. Nope. So setting that to... See, the thing that's confusing me with this is that these sizes kind of don't make a lot of sense. Because, I mean, the X offset, that area is only 1024 like wide, so 11 or 10 bits should be more than enough. Why it's 12? I guess it could be because it could be a signed value. Ah, here we go. Okay, 510. What was I saying? Is that just double or something then? 256 by 2. Make and reopen. Oh. Hold on. I need to full screen. I need to full screen for this. I think I think we've got it. Because I mean, if I turn this on, you can see the drawing offset 0, 0, 0, 256, 0, 0, 0, 256. And that looks right. And I mean, if we turn off that and hit resume, it works. Finally. Oh. Okay. That means that this is now actively rendering each frame, which is important because that means I can make a really simple change and we'll get a triangle moving. So down here, if I just const cxbr u32 try x equals 1. 32 const cxbr u32 try width equals 64. So we have triangle x plus width over 2. I'm gonna skip this song. Oh, that was the end of that playlist. Hold on. There we go. And then this would just be try x plus try width. I'm on multi. Okay. Make, and that should look the same. It should just give a static triangle, which it does. Okay, cool. So we can now just make that a regular variable here, actually. And we can just say try x plus. And if we swap to our multi-view, oh no, swap to our main view, and hit run, we should just get our triangle just walking across the screen. And we do, thanks to double buffering. Well, it's not actually double buffering that's doing that, but you get the point. We're now actually rendering it constantly instead of just kind of rendering it once, we're rendering it constantly, which is what we were aiming to do. So we did it. Hooray! If I swap back to the code real quick. So, yeah, I mean, we got what we were trying to do. I guess there's still some questions with this part, or with this stuff with drawing offset though. So like, the offset X seems to be 12-bit. Presumably it's signed then, instead of an unsigned value, which I know that some people probably don't realize what that means. Signed just means like it can be positive or negative, whereas unsigned is just it's only positive. Yeah, I don't know why that would be signed though, because none of the other values with that are, and that is, to my knowledge, not relative to anything. So, who knows? Who knows? So you know, there's a mystery to clean up there, but I mean, hey, you know, we got it working, so I'm gonna take that as a win. Yeah. Hold on, let me. sort this. One second, one second. Okay. The text is not wanting to align, but whatever. Um, yeah, I mean, honestly, I think I'm gonna call it that. I'm actually, this was a success, but she got it kind of working. There's obviously, things I need to do that, and I need to figure out, if that value actually is signed, and if it is, why. Um, because I really don't know why it would be. And also I need to figure out if the X value is signed there, is the Y value also? I don't know. But regardless, I'm pretty happy with what we got. Um, so yeah, yeah, yippee. So yeah, I'm gonna call it there. Thank you everyone for being here. Um, I don't know if I have much else to say. Um, yeah. Okay. Goodbye, chat. Bye bye. Goodbye. Bye bye. Bye bye. Goodbye.